Okay, so what we're doing here is finding the solutions or roots of a polynomial equation in factored form. Roots is just another word for solutions of an equation. It's usually used when we talk about polynomials. We did this with quadratics also. They just didn't have as many factors. In quadratics, we might have had something that factored to this, and then you had to figure out what were the solutions of this. This is just like with quadratics, it's based on the zero product rule, which says that if you have a times b equals 0, then either a equals 0 or b equals 0. So like back in quadratics, one of these two things had to equal 0, right? So either x minus 4 equals 0, and then you just solve for x, or a lot of times we just did this in our head, but some of these down here we won't be able to do in our head. All right, so x equals 4 is one of the answers, and then of course the other possibility here on this quadratic is that x plus 1 equals 0. Take away 1 on both sides, you get x equals negative 1. So our solutions are negative 1 or 4. Those are also considered the roots of this equation. All right, so how do you do it for, what if we have more than two factors here? We have like a times b times c times d times etc. equals 0. Well, that just means one of those things must be equal to 0. Either a equals 0, b equals 0, c equals 0, etc. So looking at this first example, this means that either x equals 0 or x plus 4 equals 0 or 4x minus 7 equals 0 or x minus 2 equals 0. And then we just solve each of these equations. This one's already solved for. That's one of our answers, 0. How about that? And now here we would take away 4 on both sides. We get x equals negative 4. On this one, we would add 7 on both sides and divide by 4. So 7/4 is another solution or root. And then here we would add 2 to both sides, so x equals 2. So that means, I'm not going to be picky on how you write your answer, but the official way to do it again is with the curly brackets and list the answers in order from least to greatest. So we would have negative 4, 0. 7/4 is a little bit less than 2, right? 8/4 would be 2. So 7/4 and 2. There we go. So those are our roots or solutions. You guys go ahead and do this your turn over here. Here's what I got. Again, I just took each factor and set them equal to 0. I did a couple of these in my head. Also, there is a shortcut for this style, which we learned about last unit. If you want to use that shortcut, you can. I did it the long way. So my answers were negative 2, negative 3 halves, 0, and 5. Okay, it's pretty much the same idea for all of these. They just get a little bit more complicated as we go. So here we have x squared minus 5. That could be what equals 0 in this equation. Or it could be that x plus 2 equals 0. Let's do this one first. This is the easier one. You just take away 2 on both sides. Boom. X equals negative 2. That's one of our solutions. Over here, though, if we add 5 to both sides, we get x squared equals 5. And we need to solve this equation, which means we have to take a square root. So we take a square root, we get x equals, don't forget about the positive or negative. And you can just leave it as the square root of 5. You can't reduce that at all. So our solutions here are, and again, I'm not going to be too picky on how you write the answer, but technically you would write it like this, negative 2, and then you would do the negative square root of 5, and then the positive square root of 5, okay? If you wrote positive or negative square root of 5, that's fine. Okay, so there we go. You guys do the your turn over here. Here's what I got. Again, set each of these equal to 0. Just got 3 over here. You can just put in 3, you get 0. And then this one I just set to 0. I had to take a square root here, right on that step. And yeah, I got x equals positive or negative square root of 7. So I got 3 solutions, negative square root of 7, positive square root of 7, and 3. Okay, it just gets a little bit trickier each row here. This time, again, you can go x to the third equals 0, and in fact, you can kind of ignore to the third power. It's not going to matter. Either way, x equals 0. And then we have x squared plus 4. That could be equal to 0. And then the last thing is 3x minus 2 equals 0. It doesn't matter. You don't have to put to the fourth power. If you can kind of ignore that. Whatever we get in here, that will make the inside of the parentheses 0. Well, if 0 to the fourth power is just going to be 0. Okay, so that'll come out to 0 that way. So you can kind of ignore these exponents. I could have done it here, also ignored that exponent. You can't ignore this exponent, okay? But if it's on the outside of the parentheses here, then you can ignore it. So that's one of our answers. This one here, if I go to solve for x, well, we get x squared equals negative 4. Then I have to take the square root of both sides. And so we get x equals positive or negative square root of negative 4. Ooh, you know what's coming here? We have an imaginary number. So the I comes out, and then of course we have square root of 4, and that's just 2. So x equals positive or negative 2i. Okay, I switched the order there too. But all right, so x equals positive or negative 2i. And then over here, this is just like one we had before. You just add 2 to both sides. And 3x equals 2. Divide by 3, you get 2/3. So our solutions, or roots, are then 0, 2/3, and then you can either list them out separately or together, positive or negative 2i. All right. You guys go ahead and do the your turn. All right, so here's what I got. I just did these two in my head, and then I wrote this one out a little bit. So I got 0, 5, and positive and negative 3i. You might be wondering, what are the rules about writing these in order when you have imaginary numbers involved? And I am not sure. If you can find that out, I'll give you some extra credit for that. But what I would think, what would make sense is to group all the real answers together and then all the imaginary answers together. But I'm not sure if there are any rules even, which ones go first. So don't worry about that. I'm not going to be picky about that at all. Okay, last one here. So here now we have, again, 3 factors. Well, this one's a double factor, we might say, but in order to find the solutions here, I need to figure out when this first factor is equal to 0, and then this 3x squared plus 1, when that's equal to 0, and then when the x minus 5 equals 0. What values of x would make all of these true? So this first one here, ooh, that's a little bit different. I need to solve that. Quadratic. It's a quadratic I have to solve. So you could complete the square, but that would be a pain because the b here is 1 and you get a fraction. So what I would do is just use the quadratic formula. So a is 1, b is 1, c is 5. And then we're going to go negative b plus or minus square root b squared minus 4 times a times c, all over 2 times a. And let's see what we get here. We got negative 1 plus or minus, and this is going to be, you can put this in your calculator, of course, but I believe it's negative 19 over 2. We have a square root of a negative number, so that means we have an I that can come out. And the square root of 19 is not going to break down. And that's all we can do. So those are actually 2 of our solutions. Negative 1 plus I root 19 over 2 and negative 1 minus I root 19 over 2. Right here, we would take away 1 on both sides. We get 3x squared equals negative 1. Then we would have to divide by 3 before we do the square rooting. So we get x squared equals negative 1 over 3. Take the square root of both sides, so we're going to get x equals, this one's going to be lovely. We get positive or negative square root of -1, and then I'm going to go ahead and do this. So we have an I up top, but also we have an irrational denominator, meaning we have a square root or a radical root in the denominator. And so we need to get that out of the denominator. So here, this is what I'll do first. I'll go ahead and just rewrite this as I. And then I got to go times square root of 3 times the square root of 3. So I'm going to get x equals positive or negative. It doesn't really matter if the positive or negative is on top or out the front. I'm going to keep it out front. I root 3 over square root of 9, which is just 3. So there we go. There are two more roots. And then this one's pretty easy. This is just 5, right? Just add 5 to both sides. So x equals 5. Okay, so I'm going to have to go outside the box here and write the solutions for this one. So I have x equals -1. Yeah, I'm going to go ahead and just write them together. The positive or negative versions, you don't need to separate it out. And then we have positive or negative I root 3 over 3, and then we have 5. All right, you guys do your turn for that one. All right, so here are my answers for that one. The first factor, the solution or the root would be 3. And then the second factor here, to make this 0, well, you have to use the quadratic formula, and you end up getting this, which the square root of -8, that simplifies a little bit to 2I root 2. You put that back in for the square root of -8. The 2's all cancel here. You're left with -1 plus or minus I root 2. And then over here, you take away 5 on both sides, take the square root, you end up getting positive or negative I root 5. So here are all the roots of that polynomial.